All right, so let's quickly open to a fresh page and then let's begin our calculations from there. Okay, so that is, we are coming to problem 1.4. Yes. So let's quickly continue from problem 1.4. And this is our problem 1.4. Good. Exactly. Okay. So this is our given. This is our given. Okay. So let's quickly enumerate our given down. And from there, we see how best we can analyze the question. Okay. They say we should find the minimum diameter of. Take note. Always remember to visit the question and try to read the question more often. Okay, to be sure of what you are supposed to look for. You don't just read the question once and move on. Continue coming back to the question and keep reading the question. Okay, so that at the end of the day, you can be more learned or well concerned about what you are supposed to look for. Okay, or to be sure of what you were assuming was what you were looking for. Exactly. So the question says, find the minimum diameter of a steel wire which is used to raise a load of, let's say, 4,000 Newton. Good. So let's quickly see if we can draw that before we even start writing our given. Okay. So let's say if this is the load of 4,000 Newton. So this is it, 4,000 Newton. 4,000 Newton. Okay. And now this over here, something is used to raise this. Okay. So this rope is used to raise this. And this has a minimum diameter of that. Okay. This has a minimum diameter of that. So this continues like that. And it has a minimum diameter of D, okay, which we don't know that we are supposed to look for. That is the D we are supposed to look for now. You see, that is the D they are telling us to calculate for. Which is used to raise a load of 4,000 if the stress is not to exceed, let's say 95 meganewton. So the stress is not to exceed 95 meganewton. Okay, so the stress, let's quickly put that down before we start writing our given. The stress, okay, is not to exceed, okay, that is must not be greater than, okay, so this is how I write it. Then I'll cross it. It must not be greater than what? 95 mega Newton per meter square. Please, anyone having any question to ask before we proceed? Any question, any challenges, any contribution before we proceed?
Please, I have a question.
All right, thank you. Quickly ask your question.
Is it compulsory to draw the diagram?
The diagram can attract more marks than you can ever imagine. Okay. Yes, and this is where your real creativity comes on board. You being able to just bring theory into real life, just theory into meaningful, theory into virtual, it's a plus. Do you understand me? Because it is
Okay.
something that not too many people will be able to do. Okay. Yes. So you always try
Okay.
to do something outside the box so that at the end of the day, you can fetch more marks for yourself. All right.
Okay.
So thank you very
Thank you.
much also for that. So at the end of the day, what else? So we have been asked to calculate for the minimum diameter. So you see, the one we are supposed to look for now is the what? Minimum diameter, which we don't know. You see. So just this two, we are good to go. If you like, we can still write down some of these things and then to make life much more easier so that we can proceed to solve our question. So our load is 4,000. Let's quickly write it as part of our given. So it is 4,000. And then what else again? The stress that was
Press.
given was 95 meganewton
Per meter square.
per meter squared. Okay, good. And this is the same as what? 95
95 times 10 to the power
times 10
exponent
exponent 6 Newton per what?
per meter millimeter square.
Relax, per meter squared. Okay, but this is not the end of this. This can still be expressed in what? Other terms. We will come back to this shortly. What other thing are we left with? Let's go
Next.
back to our question again. So if we are done bringing all other our parameters out, our D, which we know we are being asked to look for, that we still don't know, we are still searching for it. And who other? Okay, so we are supposed to convert this. Okay, we are supposed to convert this guy into Newton per millimeter squared before we proceed. Okay, and this is where I needed the most. So without beating about the bush, let's see how we can convert this into what? Newton per millimeter squared. Okay, so over here, let's say we have 95. So let's begin from just this page. So we are having 95 meganewton per meter squared. This is what was given to us. And we are saying that this, from prefixes we learned just recently, this is the same as 95 times 10 exponent 6 Newton per meter squared. Okay, good. Take note that whatever I've written over here can also be written like this. Okay. What you are seeing over there can also be written in this form. It can also be written as 95 times 10 exponent 6 Newton per meter squared. Okay. But in this case, I can also write it this way. Do you agree with me? Do you all agree with me, please?
Yes.
Yes, I'm writing this way because even this guy you are seeing over here can also be written as what? Let me quickly draw a circle around it for you to see. I want to express it in so many forms so that when you meet them somewhere, they don't scare you much. Yes. So this is 95. This can also be written as 95 times 10 exponent 6. Okay. Newton, let's say times 1 over what? Meter squared. Do you all agree with me? Because I'm saying this because the other day I told you that the other day I remember exactly. I told you that if you see this somewhere, if you see Newton per meter squared somewhere, it is the same as what? Newton per meter what? Squared. Okay. And also I remember telling you that any number exponent -2, any number exponent -2 is also written as what? 1 over that number. Do you understand me? And so this is also written as what? If you see dot, it also means multiplication. So this is also written as n multiplying what? 1 over what? Meter squared. I hope we all remember this concept. Okay. So from that same concept, that is what I have transferred over here. Take note, how many meters is going to give you millimeters? The other day we said that 1,000 millimeters is equal to what? 1 meters. So let me draw a very big circle over here, and then we dissolve that in it. The other day, so the other day, from whatever we learned from our graph and from the song we learned, what did we say? Okay, if we want to look for the formula for that, remember that that is going to be 10 times 10 times 10. Okay, so 10 times 10 is 100 times another 10 is 1,000. So at the end of the day, realize that 1,000 millimeters, that is 1,000 millimeters is equal to what? 1 meters. Okay. So what about if it is a meter squared? So if 1 meter squared, or if 1 meter is equal to 1,000 millimeters, then it means that if it is meter squared, we just have to square the other side. Okay. So I'm going to transfer this concept to whatever we are having over here. And we are saying that 1,000 millimeters, that is 1,000 mm, is equal to 1 meter. Okay, so for this one, all of this is exponent 1, exponent 1. Please don't get confused. This is exponent 1, this is exponent 1. Okay, so what of the case in exponent 2? For the case in exponent 2, if this is meter squared, then it means at the end of the day, you are just going to square whatever is in this. Okay, so this is also going to be what? You just put the whole of this into bracket. You see, so finally, what are you going to get? You're going to realize that the formula you're going to establish, okay, since this is like a constant you are using, or since this is a formula that you're using to solve your work, at the end of the day, if you increase the exponent by 2, you realize that it's also going to affect whatever that is in this to also increase. Okay, so finally, you're going to get what? 1,000, or let me say 10,000 what? 10,000 millimeter squared. You see, the exponent is not going to just affect them, but it will affect the 10,000 also. So you're going to get 10,000 millimeters squared is equal to what? 1 meter what?
Please, you've written 100,000. It's more than 10,000. It's 1 million.
So let's
It's
all
1
do this
million.
together. Let's all punch that together in our calculator. So you see, we are going to get what? 1 million. So
what you've written is 1 million.
Yes. So that
The
is
zero
what.
should be 4.
Please, let's all punch this together on our calculator quickly, and then we proceed, okay? This is what we should all be getting. Quickly, just punch this on your calculator. If you can't punch, let a brother help you. As simple as that. As simple as that, okay? So you see, our rule over here that we have established is what? 1 meter squared is the same as what? 1 million, okay? So whatever I've written over here,
1 million, okay.
whatever I've written over here, I can map it over here. On this note, I continue to say that the laws of physics are the same for all observers in uniform motion relative to one another. At the end of the day, someone is reading civil engineering, someone is reading electrical engineering. The laws, we are all applying it differently, but you realize that if only we are speaking the truth, the units will always speak for themselves, okay? And they are always going to be equal. You understand me? That is only if you are speaking the truth. So at the end of the day, our formula we have is what? Let's say 10 exponent 6, okay? 10 exponent 6 millimeters squared is equal to what? 1 meter squared. Okay, so that is the formula that we have now. Okay, so wherever we see 1 meter squared, we can put what? 1 million millimeter squared over there. Okay, so as writing this again, how can we write this? Now we have now find the truth. That means that what? Our 95 times 10 exponent 6 Newton per meter squared can also be written as what? 95 times 10 exponent 6, okay, Newton over what? In place of the meter squared, we can now write what? 10 exponent what? 6 millimeter squared. Okay. And as a continuation of this, how can we dissolve this? Because I want everyone to have a clear view of whatever I'm doing, I want to repeat this step one last more time, even before I begin to cancel. Okay. So let me draw a circle around this to highlight this as a very, very important point. Finally, what can we realize? We realize that we had 95 times 10 exponent 6, okay, Newton per 1 million millimeter squared. So we can do some cancellation out. Okay, so realize that this guy will take care of who? This guy. Finally, who are we left with? We are now left with
95 Newton per millimeter
95
square.
Newton. We're now left with 95 Newton per what?
Millimeter square.
Squared. Okay. 95 Newton per millimeter squared, which can also be written as the other way around. Okay, so this is the answer we had. So finally, we can say that therefore, our final answer was 95 Newton per millimeter squared. Exactly. So this is the answer we had. So you see now in place of that, we can put this over there. This is the answer we had. 95 Newton per millimeter squared. Okay. So you see after the convention, what we had. So we see that can also be written as what? 95 Newton per millimeter squared. At this point, I want to pick some few questions from you before we proceed. Any question, any contribution, any challenges before we proceed with the class? Any contribution, any challenges? Hello?
Hello, sir.
Yes, sir. Please, was there
Hello.
any? Yeah, please, I'm listening.
I just want to ask
Okay.
the unit, the bigger unit, is it compulsory to? I said the unit. Is it
Yes.
compulsory or necessary to change the bigger unit
We are working in Newton per
into
millimeter
smaller
squared.
units?
Yes, we are working, we have chosen to work in Newton per what? Millimeter squared. Okay.
Hello?
So you have to do all your calculation in this. Newton.
Hello?
Yeah, hello, please, I'm listening. You have to do all your calculation in Newton per millimeter squared. If your calculations are not in Newton per millimeter squared, you are not precise. Do you understand
Hello?
me?
Okay.
Thank you very much. Sorry, Bernard, please kindly ask your question.
Please, for the this one, how you get the 95 from? Is like I'm quite confused about that size now.
You are confused about how I had a 95.
Yeah, how the
Yes.
millimeter cancel, like how it becomes 10 exponent 6.
How it became 10 exponent 6. Okay,
Yes.
so let's come and take it one last more time again. Initially, what were we given? Initially, what were we given? We were given what? 95. This was what we were given.
Mega
90.
Newton.
Please, I want everyone to be quiet, okay? Initially, we were given 95 meganewton per meter squared. And this is where I have placed the asterisk. Okay. This is the equation we were given. Or this is what we were given. It's good. So I told you that the meaning of the mega is what? 10 exponent 6. It is a prefix, right? Good. And this unit over here is the same thing I have still repeated over here, Newton per meter squared. Do I make sense? I went on to tell you that this over here you are seeing can also be written as what? 95 times 10 exponent 6 Newton per what? Meter squared, because whatever you are seeing over here, if you see something like this, that was when I was making emphasis on this. If you see something like this, Newton per meter squared is the same as this, okay, that you are seeing over here. And that also is the same as also this that we are seeing over here, if you could remember. Because I told you that 2 exponent -1 is the same as what? 1/2, right? So from that same concept, that is why I was telling you that our 95 meganewton per meter square that was given to us can also be written as what? 95 times 10 exponent 6 Newton over what? Meter squared. And that is what I believe I came to tell you in this equation 1 over here. Can you see this? As a continuation of this, I went straight to the table that I taught you the other day. Yes, I went straight to the table I taught you the other day. And as part of the table, we learned a song. If we could all remember the song that we learned. From the song that we learned, what did you realize? We said that what? 1,000 millimeters. This is the rule we established. 1,000 millimeters is equal to what? 1 meter. 1,000 millimeters is equal to what? 1 meter. So if 1,000 millimeters is equal to 1 meter, that becomes our general, it's like our general formula that we are working with. Okay. If we want to establish more formula from this, what can we do? If we want to establish more formula from this, the first one, so this is exponent 1, this is also what? Exponent 1. Okay. So you realize that as this is increasing, as the right hand side is increasing, the left hand side is also increasing. Okay. So let's produce the rest of let's generate the rest of the formulas on our own. Okay. So this, if this becomes what? 1 meter squared, then this is going to be what? 1 million. You see. You see, millimeter squared. The same way, if this becomes what? 10 meter cube, this one is also going to be increasing that way. Okay, so that is what is happening. That is what is happening. Okay, that is actually what is happening in the scientific world. Do you have any other question? Are you okay, or you wish I could still throw more light on that for you?
Please, I'm okay.
Okay, so you see what is happening over here. Are you following what I'm doing over here? So
Yes,
if
please.
you increase the exponent by exponent of 3, if you do 10,000 exponent 3, what are you going to get? Everyone should do that quickly and tell me. You realize that now the zeros are going to be 9, right? So it's going to be 10 exponent 9 what? Millimeter what? Cube. You see? If this is what? Let's say 1 meter exponent 4, then you realize that the formula you're going to use is what? 10 exponent what? 12. So it also keeps increasing by what? 3. There are so many scenarios to this. If you wish, I could give you more scenarios. Okay. So please, if everyone is okay, then we can proceed. But if you are not okay, then I'm going to continue to throw more light on this as we continue to make history. Are you all okay? Can we proceed?
Yes, sir.
All right.
Yes, please.
All right. So because of that, now from that formula, that is why I'm saying that anywhere you see meter squared, how many millimeters can you put over there? You can put 1 million over there, you see. So that is what is happening over here. Now, in this case, we saw what? 1 meter squared. So that 1 meter squared we are seeing over there, if A is equal to B, then it means that what? B is also equal to what? A. If A is equal to what? B, then it also means that what? B is equal to what? A, right? So that is it. So in place of 1 meter squared, I can put what? 10 exponent 6 millimeter squared over there. 10 exponent 6 millimeter squared over there. That is why from equation 1, we came to get equation 2, if you can see clearly. Can you all see my equation 2? So in place of me writing 1 meter squared, I came to write what? 10 exponent 6 millimeter squared. C'est fini? All right. So at the end of the day, you realize that this 10 exponent 6 can cancel this 10 exponent 6, and we are going to just be left with what? 95 Newton per millimeter squared. And that is how I had this answer we are all seeing over here. Are we all okay? Or I should still throw more light on that?
Yes, I'm okay.
Okay. That is cool. I need more questions. In fact, anytime you are coming to class, make sure to learn very well and be prepared to ask challenging questions. Always be prepared to ask questions that the lecturer cannot answer. Do you understand me? Anytime you are coming to my class, that is how I want you to prepare like a soldier. Do you understand me? So that in doing that, that is how you are going to become more creative, and that is how you are going to become more dynamic, so that you can have so many ways to solving so many problems. If you fail to ask more questions, you're always going to be behind. You understand me? So you should always be curious. Yes, so that is it. So this is our solution. This is our solution. What was the question asking us to calculate for? Can someone read the question for us one last more time? So the question said we should calculate for our stress. Stress was what we were being asked to calculate. The maximum diameter, okay, the minimum diameter. So we know that our stress is equal to force over area. That is P over A. Okay. In this case, the force is known, but the area is not known. Good. So our P was equal to 4,000 Newton. Now, as we can see, this area that was not given to us, we can express the area in terms of what? The formula. Okay. So let's quickly express the area in terms of the formula. And this area over here can be what? Expressed as what? Pi d squared over 4. You see? So finally, we can rewrite this again, and then we can take our calculation straight away from here. You see? So this over here is the same as what? 4,000 Newton. All over what? Pi d squared over 4. Pi d squared over 4. So from here, our pi is known, our d is not known, okay? And also, our stress is known, okay? So we can make d the subject from this relation. Then we are good to go. So we are going to make d the subject from this relation. Please, everyone, I expect each and every one of us to pay more attention. Okay, so we are just going to make d the subject of this relation. It's just left with just 10 minutes, and I wish we could all pay attention so that I can quickly solve this and then we proceed. What was the value for our stress? Our value for our stress we calculate for was 95 Newton per meter squared, per millimeter squared. So 95. For the meantime, let's put the unit aside. So that is 95 is equal to 4,000. Okay. All over, let's say, pi d squared over 4. You see, if working with, let's say, if working with the numbers will be a problem, you can choose to work with the units. Okay. Yes, so that at the end of the day, you don't confuse yourself much. If you are done making the change of subject, you can still do the substitution, and life becomes much more easier. So let's use the symbols. So this is our stress, and this is still our P over here, so that we don't confuse more people, okay, for viewers purposes. Also, don't forget to subscribe to the YouTube channel. Don't forget to like, share, and comment for more. Okay, in case you find any challenges, don't forget to see me in person. Also, in case you find my videos very useful, don't forget to throw $1 on my name when you happen to see me or find me in person. So let's quickly solve this. I told you that anytime you say this is divided by 1, but some cases we may write, some cases we may not write it. If you do the interpolation, you are going to get what? P times 1. So this is P multiplying 1 is equal to what? Your stress times over here, pi times what? The diameter squared over 4. Okay, good. This that I've written over here is the same as what I'm coming to write over here again. So this is the same as what? P is equal to what? In rewriting this, this is going to become stress multiplying pi, okay, times the diameter squared all over what? 4. Okay, so you see over here, another cross multiplication can also go on again. You see, so the P is going to multiply the 4. Let me quickly use a different color pen to be on a more safer side for viewer purposes. Okay, so P times 4 is equal to what? Our stress times the pi times what? The diameter squared. Finally, what are we left with? You realize that we are left with this relation. So we just have to make D the subject. Okay. So let me quickly maintain this step one last more time again. This is going to give us what? 4P. Always remember to write the numbers before you write the what? Alphabet. 4P what? Times what? Stress times the pi times the diameter squared. Because we are looking for the diameter, we can divide both sides by what? Stress times pi. We can also divide here too by what? The stress times the what? Pi. Okay. Let's do our cross. Let's cancel out. And when you realize after cancellation, you realize that this will take care of this, and this will also going to take care of the other one. Exactly. So this will take care of this. Okay. So finally, we are left with what? 4P. We are left with 4P over stress multiplying what? The pi is equal to what? D squared. I told you that if A is equal to B, then it means that B is also equal to what? A. Okay. So let me rewrite this word and then we proceed. So that is, this is also the same as what? D squared is equal to 4P all over pi times the pi. Stress times the pi. Okay. So from here, if we want to get rid of the square root sign, we have to root both sides. You see, we have to root both sides. So I'm going to root here. I'm going to root here. And you see what is going to happen. This guy will take care of this guy. Okay. But for precision purposes, let me quickly maintain this step one last more time again before I do the cancellation out. I just want to be more transparent so that at the end of the day, I don't leave any piece of information out. Do you understand me? It's very, 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 very much important. So this over here, at the end of the day, that too is going to get rid of that. And then life is still much more easier. This is not only solo to that, but it is actually for all. So this cancel that and it continues. This will take care of this. So finally, we are left with what? D is equal to root of, let's say, 4P over what? Stress. But let's bring the pi first. Pi multiplying the what? Stress.
Stress.
Multiplication is commutative. That is 3 times 4 is the same as what? 4 times 3. So anyhow you interchange them, you are still on the same or right path. So let's quickly do our substitution and substitute our variables into the formula and see that whether we are going to get our answer or not. Yes. In 3 minutes time, the link is going to go off. I'm happy we're able to manage the time well to catch up with whatever we were supposed to do. All right, so let's quickly do this. And this is going to give us, let's do the substitution. So the pi we are using is 3.142. Okay.
142
95
times 95.
Let's come to the numerator.
Okay.
4 times 4,000.
4,000.
So 4 times 4,000. 1, 2, 3. Good.
Right.
So quickly solve this for me and tell me the answer and let's proceed.
We had,
So the diameter, you see, because it's a diameter, I told you the unit of all the quantities the other day. So because it's a diameter, you should know what the unit is going to be. Because it's a diameter.
millimeter.
So good.
7.32.
Okay, so please, what answer did you get?
7.32 millimeters.
7.3214.
It is wrong. The one who added the unit to his answer, it was even more
millimeter.
precise, though his decimal places was not sufficient. Okay, if you fail to add your unit, you are always remember to add your unit to your answer. If you fail to add your unit, it is just wrong. Okay, yes, that is why we taught you the base quantities. So the answer is actually 7.3214
7.3214 millimeters.
2
millimeters.
2. Okay, so I'm writing more decimal places because I need more marks. I need more marks. Do you understand? I want to be more accurate. I want my answer to be more close to the standard result or standard value. So the answer we're going to get is what? 7.321416.242 millimeters. You can choose to maintain your answer in 4 decimal places, 5 decimal places, or 6 decimal places, but the standard should always be 4 decimal places. Okay. Please, the trial questions, I have not forgotten. Try and work them. Try and work the trial questions and then send me so that I review them for you. Okay. When we happen to meet in person, we are going to be solving some of these trial questions. If we meet in person, this is the work we are going to be doing. We are going to be solving some of these trial questions. Okay. So apply the concept on whatever we have learned so far and see if you can be able to solve some of these questions. Okay. As a matter of fact, these are even mostly some of the questions that come in exams. Okay, the trial questions. The answers have been provided over here. So you can try many times. If you don't get the answer, try and try again. You may get the answer. If you don't get, let someone assist you. Okay. Yes. If I'm here today, maybe I'm also teaching you. It's because I got it right because I failed several times. Okay. So please don't be discouraged when you try 1, 2, and you fail. Keep practicing, and life is going to become much more easier.